Okay. By now you should have read this, as always, before watching the video. And this one talks about a driveway where it is snowing, and they make it a point to say that after 10 minutes, Joe had measured 2.0 centimeters of snow, and after 30 minutes, there was 3.6 centimeters of snow, and the snow continued to fall at the same constant rate. And then Joe graphed a line to represent the snowfall. Rate, as always with the keystones, will probably mean slope. Okay? And then look at part A. What should be the slope of Joe's line? Well, I think plain and simple, I'm going to kind of use the fact that we can find slope from two ordered pairs. Like we do have two pairs. Okay? We have a pair of where 10 and 2.0 make a pair together, a minutes centimeters deep pair, and then 30 and 3.6 make another minutes centimeters pairing. Okay? And yeah, that's kind of what I'm going to go with here, that 10 comma 2, or I'll just go ahead and write that as 2.0, I guess. And another pairing is 30 comma 3.6 is the other pair. And when we go ahead and use our slope formula, it's going to be the change in these numbers. Like I guess I'm considering these the y values. So the centimeter excuse me the centimeters is going to basically act as our y value, and the number of minutes is going to act as our x value. So when we do calculate the slope, it's going to be basically centimeters per minute, which makes sense. The rate translating into the slope, that rate is going to translate into centimeters per minute or something. And so it does make sense for the number of centimeters to be our y value, our y coordinates, and the number of minutes to be our x coordinates. So now all I got to do is kind of plug this stuff on into our slope formula, which I'll take the time to actually write out in its original form. And, I'm just going to go ahead and consider, you don't have to do it exactly, it doesn't matter, but I'm going to go ahead and consider this my second y coordinate, and I'm going to consider this my second x, my x2 and my y2, just because it was kind of like our second ordered pair. So when I plug these numbers in, it's going to go like this for me. So y2 minus y1 all over x2 minus x1, and that's going to get me 1.6 all over 20. And now it's kind of like, well, where do we go from here? If I literally divided that, I believe we would get 0.08. Let me double check on a calculator. Yep. And so I don't know. This question doesn't really get specific enough in a lot of different spots. But and this is one of them. It's like, is 0.08 a good enough answer? I would think so, but as a fraction, what does it say, like 8/100ths? So as a fraction, and you can, and there's calculator functions that you can use to like literally just transfer decimals to fractions. But that would translate, sorry, excuse me, to 8/100, which would reduce to 2/25. So, I mean, arguably that would be like the bestest answer because it's in fraction form. But I would assume that 0.08 would get you the points. I don't know. So that's the answer to part A. Part B, we love these. Explain. Explain what the slope means in this situation. All right. I don't know what that is doing there. Oh, that's what it's doing there. What the heck? So, like, it's kind of... Alright, whatever. Anyway, explain what the slope means in the situation. Well, I think I already sort of addressed it, didn't I? The slope or the rate, you know, change in whatever over change in whatever. So that's going to be like the change in centimeters compared with the change in time, the change in, minutes? Because remember, the slope means rate. On the keystones, slope and rate go hand in hand, okay? So what did I write here? In this situation, the slope means the number of centimeters of snow falling every minute. So that would be 0.08 centimeters every minute, or you could even go above and beyond and say that, or say that we are increasing 2 centimeters every 25 minutes, or 0.08 centimeters every minute. But you can just use the words. This is reasonable means the number of centimeters of snow falling every minute. In other words, it's the rate of snowfall. Yep. Part C. Write the equation for... Well, we already have the slope. To write the full equation, so we already know the slope is 0.08 or 2/25. I guess I'll just go with 2/25. And let's see here, we got 10, 2. So I don't think I've done this in a video yet. Let's use this form or formula to get ourselves an equation. You know what I'm going to point out right away, already, is that they want an equation. They're not specifically asking for a certain form. And I don't think there was like a spot at the bottom where it says like, put your final answer here, and they put a y equals there, and which would pretty much, that's, that would be pretty clear what form they want it to be, and they want the y to be by itself. But I don't think they did that in this problem, so not the best problem the way it was written. You'd think I would think they would be pretty specific about what form they want the final answer to be in. I don't know. So look, to use this formula to get an equation, we need to know M and we need to know B. But we don't know B right now, okay? Like, that's kind of the thing. But we can still use this equation by plugging in a pair for X and for Y, and then we can solve for B. Well, you'll see, right? So I think our slope we're going to plug in is, what, 2/25, I guess? And then what's the point we're plugging in? 10, 2? 10, 2. So we're going to plug in 2 for y, and 10 for x, and we got this. So we got 2/25 times 10 plus b, okay? And 2/25 times 10, we could leave this as a fraction, but I think in this case it'll be pretty, so that's 0.8 plus b, and so solving for b, we get 1.2 equals b, which I think that should be fine, in decimal form. I mean, it's not like we rounded it into a rounded decimal, so I'm assuming 1.2 should be just fine. And now that we know that b is 1.2, we can write our final equation of y equals 2/25 x, or I'm assuming 0.08 would also be fine for your m value, plus 1.2. Now, just to and to be again like super thorough with these videos, you also need to be able to use that formula. And so I'm going to do y minus, let's see, our point was what? 10, 2. So once again, we can plug in the slope we know, and even if that was written as like 0.08, that should probably be okay. And plugging in 10, so we got 10, 2. And again, if they're not specifying what form this is an equation. So based on their very vague directions, this should also be an acceptable answer, right? Of course, you could keep this going. 2/25 x, again, I'm distributing to clear the bubble, minus 0.8 is what that is. And then you would add 2 to both sides to solve for y. Get y by itself. And negative 0.8 plus 2 is, so either way, no matter what strategy you use, if you were going to finish off in y equals mx plus b form, you'd get the same answer, of course. Anyway, let's move on to part D and finish this up. How many minutes should it take for the depth of the snow to reach 8 centimeters? Okay. So when you get questions like this is classic Keystone questions. Okay, this is a classic where you have an equation, that involves a couple variables, where in this case one variable means number of minutes and another variable means number of centimeters, and then they ask you this question. They're essentially asking x equals what when y equals 8? Because wasn't our y variable a number of centimeters? Yeah. So what was our equation? Y equals, and you know what? I'm just going to go with I'm going to turn my slope into a decimal just to kind of keep things interesting, just for some variance, for some difference. And again, here's what you would do. It's like they want you, it's like in a way they're telling you, plug in 8 for y and solve for x. Because if they're telling you a value of centimeters, that's a y variable. And they're asking for what the x value is when y equals 8. And so now we just got to get x by itself. Solve for x. What is this, 6.8? So we have just 0.08 x over here. 6 minus 1.2, it should be that. And so we're going to divide by that to get x by itself. Calculator time. 6.8 divided by 0.08. 85. So your final answer, it's always best to include units, just in case. So does that make sense? That it would take 85 minutes for the snow to reach 8 centimeters. Did you have to do an equation and plugging in values? I guess not, but I think you should know about this kind of problem-solving situation and technique. So 85 minutes to reach 8 centimeters. Again, you know the rate. You know you're increasing 2 centimeters every 25 minutes, or you know you're increasing 0.08 centimeters every 1 minute. Like, you know the rate. So you should be able to kind of like plan out, or with a little table or a little, I don't know, calendar, a little whatever, I don't know. You should be able to kind of plan out and just make little jumps and jumps and jumps and figure out that it would take 85 minutes to reach 8 centimeters.